An effect we're going to be having a look at here is the way we can get a pencil to seem to sketch out a curve like this, which is a somewhat more interesting way to look at a curve. Instead of it just appearing in one hit, we have the effect of it being almost like a hand-drawn curve that goes through those points. So let's have a look how we can do that in GeoGebra. And we'll just start by introducing a function. So in this case it was an exponential function, so I'll just say 2 to the x, and it will draw our curve on the screen. And it's called that f as it was introducing it. So what we'll do is we'll make that depend on a slider as well. So we'll drop in a slider here, and it can be called a, but I would like it to start being positive. So that just constrains it to go from 0.1 to 5. And then we can just make the function depend on the value of a. So if we double click the function, we can replace the 2 to the x with a to the x. And we now have the value of the slider sort of embedded in the function definition. Now it would be nice to be able to see the current function definition, just to be able to see this 2.7 to the x over here. So the way we can do that is we can say the formula text, and the function was called f, so we just put that in the square bracket, and we just put that there. And I might even just add a little bit of text at the start of that. So inside quotes here at the start I can type whatever I like, but I'm going to just type f of x equals, and then we'll say plus, and that just adds all that together, so we end up with just that bit of text there. And that's quite nice because we can now see the graph change and its function definition as we drag the slider. Now the thing we try to do is to get a pencil to sketch out this curve. So the way to do that is to add a point to the curve and attach the picture onto the point. So to show you what I mean, let's just have a slider which can represent the x coordinate of this point, and we'll call it xc for x coordinate. It can go from -5 to 5, and then the point on the curve will say that its x coordinate is the value of the slider xc, and its y coordinate we're going to substitute that value into the function f, which means it'll stay on the curve like that. Okay, now we can drop in an image with insert image, and I've got a picture of a pencil here, and we basically want the pencil tip to be attached to the point P. Now our first sort of approximation of that could be we'll just try to attach the corner, so the corners are labelled sort of 1, 2, 3, 4 in an anti-clockwise direction on the picture. So we'll say let's just attach corner 1, which is the bottom left corner, to point P. And you can see obviously that that's not exactly right, but it's getting close, because as we drag the slider then the picture is attached to P, but it's attached by the corner on the left, which isn't quite the thing we want. We want it to be attached by the midpoint, and because it's not a corner we're going to have to attach the two corners at the bottom here and attach them on either side of P. And the way we can do that is, let's just unattach that for the moment, is we can use a vector on the tangent line to translate P up and down the tangent line, and then we'll have sort of two equidistant points to attach the image to. So to do that we'll just introduce a tangent line, which could be done off the menu system here, or we could type it in. We'll say, so it tells me to select a point, so we'll select point P, and then we'll select the line. Now we get the tangent line has been created there, and then we want to translate P up and down the tangent line. So the way we do that is with vectors. We'll just have a quick little example of vectors here. We can type in the word vector between A and B, and we get the vector between points A and B, which we can see there. It's called that vector u, and we've also got the idea of a unit vector. So let's just introduce the command for unit vector, and if I press F1 on these things I can see a little prompt to remind me of the way that I can use them. So it's expecting the name of a vector is one way to use it. So let's just give it the name of the vector we just made, which was called u, and we now have the unit vector there as well, which is v. So let's just hide the u, and we now have just that little unit vector, which its size stays at 1 as we drag b around. Now that's going to be useful if it was on the tangent line. So we actually need A and B to be on that line, and the line is called B. Might just rename that to call you, say, line. And then what we'll do is we will double click onto B, and instead of having those coordinates, we'll say it's defined as a point on line. So let's just put B over there, and we'll do the same thing with A. We'll say it's a point on that tangent line as well. And do we end up now with A and B and the unit vector between them all on that tangent line, and they'll stay on the line as we change the value of the point. So we're going to use that unit vector to translate P up and down the line. So we'll say that P dash is the translation of P by the unit vector V, and it's just created this little P dash over here, and we'll say that P double dash is the translation of P in the other direction, and to go the other way we'll just put a negative sign in front of the name of the unit vector and it will go the other way. And then we've got our 2 points which are kind of equidistant around P. So that's probably going to be the way to attach the pencil. So we can say let's attach corner 1 to the first point, which is P dash, and corner 2 to the second point, which is P double dash. Because it's a symmetric image, it's put the point of the pencil exactly onto P, which is the effect we're after, really. Now that's too big, so we just might have to redefine the translation. So what we might say is that instead of being the unit vector, let's just say it's 0.2 times the unit vector. That just has reduced the translations to 0.2 of the unit vector. Okay, so we've got all that sort of working now, so we can turn off all the elements that we don't need to be seeing anymore, like A and B, and the name of the line and so on. Okay, so if we have a look at what's going on there now, we can drag that up and down, because it's attached to those translations of point P on the tangent line, which is exactly the effect we're after, except we also would like for the line itself to not appear until the pencil has got there. So the way we can do that is if we have a look how point P was defined, which was xc and then f of xc. Now the curve itself is basically the curve of all the values of point P all being drawn at once. And there actually is a way to sort of to draw the curve with that definition. So let's just turn off that f of x, and there's a different command we can use here called curve. Instead of calling the value xc, which will get confused with that slider, we'll call it xv for x value and f of x value, where okay, so if we just have a look at the help here, we can see that we basically need all these things in here. So expression and expression are just the x coordinate and the y coordinate, which we've already got, have typed in already. The parameter is just the thing that's changing, which in this case is going to be xv, and then the start and the end of xv. So we just say xv, so that we tell it that's what's changing, and it's starting at, say, at minus 4, say, and it can end at, say, at positive 5. Now that will draw the whole curve. It's just kind of like drawing all the values of P at once between the minus 4 and 5. And it's called this thing curve B. We can see that's called curve B. Okay. So what we can do with that is we can double click that definition again, and instead of going up to 5, we can cause it to end at the current value of that slider xc, and that will cause the drawing of the curve to sort of stop there. So it depends on that slider, and that's pretty much the effect we're after, because if we double click onto the curve and we change its style to a dashed curve and we turn off point P, then that's pretty much is the effect that we were trying to achieve. So we can just animate this slider here so it occurs automatically. We can tell the animation to only go from the left to the right. We don't want it to come sort of back down the curve. It's coming back down at the moment. It'll come back on the screen there in a sec, but we don't sort of want it to go that way. We only want it to go from the left to the right, and that's the effect we have there. Now, that seems like a little bit of work, but we actually just could redefine the underlying function to be, say, the sine of x, if we wanted to see this all occur on a different thing. And in this case, we could say that a is now the amplitude, and everything just gets redefined to work on a sine function instead. And you have that nice curvy effect there of the pencil being dragged along. So that you can see, although we had to do a little bit of work with the tangent line and the vectors and things, that having done that, then everything has just updated itself as we change that underlying function definition. So it is a technique that's easy to adapt for other functions.